a charge on here. Now, which charge do I want to pick on there? Well, I'll give you this much of a hint. You never want to pick a charge that's special. What do I mean by special? At the ends, at the middle, okay? Those are special because they're at very distinct points, okay? You want to pick some random charge on that, okay? Does that make sense to everybody? Okay, everybody okay with that? Mm-hmm. So I'm going to pick this little charge right there. Now that's exaggerated. Everybody agree with that? But I'm trying to say that little space is where my charge is that I'm going to deal with first. Okay? Because it represents all the charges that I could have picked. It's not something special. It could have been anywhere on that line. Okay? Everybody follow that? Yes? No? Maybe?
Yeah.
Okay? So is there going to be energy stored between that charge and that charge?
Yes.
Yes.
Yes. Okay? Well, so that takes care of, I know that and that, sort of. Okay? Does that make sense to everybody? Well, that means I also need to know R, don't I?
Yes.
Okay, so if I knew how far away this was, let's just call it A, keep it constant. Okay, does that make sense to everybody? Yeah. Okay? And I knew that this had a length of L. It's something between, I can figure it out. Okay? Everybody get how I can figure out R? Okay? So this is where I need to define a coordinate system. So I can do that. Now I'll give you a big hint. Used to be you just kind of randomly pick a coordinate system and the worst that happens is you got negative numbers. Now you're going to have to start really thinking about your coordinate system. Because where you pick your coordinate system will either make you or break you. Your coordinate system choice will either make your problem or break your problem. You can pick I could pick the origin to be out here and call this the positive x and that the positive y. You'd be an idiot. Okay? But you could do it.
Oh, because the way you pick the coordinate system will affect if the e-value is positive or negative.
Well, it's going to affect a lot of things. Like how easy your integral is. How easy your limits are. How easy it is to figure out what r is. It's going to affect you in so many ways. So, who wants to suggest in this case where I should pick my coordinate system? At the lowest point. So down here.
No, like on the board.
Oh, okay, so down here.
No, at the end, not the...
At the end of the line of charges.
At the end of the line.
Okay, but is that different than what you said?
Yes.
Thank you.
Huh? Okay, so we're going to pick our coordinate system to be here and here. Now, I'm going to give you a big hint, okay? May I borrow anybody's notes? Who wants to volunteer their notes to me? Okay, not too bad. I've seen worse. Can I borrow yours?
Probably going to be worse.
If this is all you've got in your notes so far, or something very similar to that, okay? I'm not picking on you, but I'm picking on you, okay? You might as well just leave your pencil sitting down. Okay? In other words, if the only thing you've written down at this point is what I've written on the board, you're going to have zero chance. Because what's the really critical piece is the
That too.
words. Okay? I'm just telling you up front. Okay? If the only thing you're going to write down is what I draw on the board, you're going to have about a 3% chance of doing these. And that 3% is because I'm feeling nice. Obviously, my real assertion was 0.03%. Okay? Now, so we got our coordinate system picked. But we have lots and lots of problems to go. Because we got a charge picked. It's interacting with another charge. So we can find the energy stored between those two. We could find R. Okay? Now, see if you follow this. See how good you are.
Is it L? Is the Y L? No, because L is the total. Oh.
Why is it Y, not L?
Because it goes up to that
Because the distance from here to that point is Y. It's not L. Which is the reason you want to pick an arbitrary point, not a special point. Now, believe it or not, so far what we've done is the easy part. Both conceptually and mathematically. Now it gets interesting. Because I'm going to rewrite this in a very fun way. And we're going to see how your calculus holds up.
Uh-oh.
Ugh. No! If it were change, I would have put a delta. No, it is not a displacement. That's a change. What did I do? Great, I added 2 letters. I'll give you a so I should just add an F over here, and
You had from your y-axis.
Okay, what do you mean? A little more detail.
Your highest y point, your lowest.
Nope. You were closer the first time, I think.
Which one's the y? Is Q2 though?
You should be able to tell me that. Because the question I have for you first and foremost is, let's start off here. What the hell does that mean? Nope. See, this is where your calculus is failing you.
Yeah.
Because d something doesn't mean with respect to. In spite of what you think you were trying to remember from your calculus class, dx does not mean with respect to x.
It's the change.
Or df of x dx. This little dx down here does not mean with respect to x, even though that's how you say it. That's not what it means. What does this dx really mean? Oh.
Stop.
Relationship.
No, but thank you for playing.
It's the
What units does dx have? Let's have even more fun with you.
great.
It has units. What units does x have? What does x mean? Horizontal. So what units would horizontal length be in?
Meters.
So what units would dx be in? Meters. Oh, so these things have units. Great. What does dx mean? It means a little length in the x direction. It's a little piece of the x. This means x, change x by a little piece of x. Yes, because what you're really doing in this is remember what the idea behind integrals was?
The infinite.
Slicing into rectangles, where the dx is the width of the rectangles. I told you your calculus was going to fail you today.
Blame it on my teacher.
Blame it on your teacher, I blame it on you. Okay? And your memories. All right, everybody okay with that? So what does dq2 mean?
Little tiny pieces.
Little tiny piece of q that's on this
Line.
line. It doesn't mean the whole charge on that line, it means a little bitty piece of it. Because the only thing my equation tells me about is the ability to do two little pieces,
Yeah,
not a line. Okay, so if this side is just a little piece of charge,
The other side would be a little piece of energy.
a little piece of the energy, because this isn't the whole energy, this is just a
Piece of it.
Piece of it. A tiny, 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 tiny piece of it.
Yes, no, maybe.
Okay? I checked out 20 minutes ago. Everybody okay with that?
Mm-hmm.
So this says a little piece of the total energy of the system is equal to Q, a little piece of the charge on the line, divided by the